Okay, so hopefully this time I am not videotaping myself. I apologize for the blurred out image, but I would prefer not to be seen as much as possible. So today we're going to do arithmetic series, and then tomorrow we'll do geometric series. So we're going to be using the formulas we already had and learning some new ones to figure out what an actual series is. So, a series is the indicated sum of the terms of the sequence. In other words, it is the sum of a sequence. So, in the last 2 days, like 2 days ago, we did arithmetic sequences. So, we add to get to the next term. So, the only difference between what we were doing then and what we're doing now is if you notice that a sequence is just the set of numbers, and the series is when we add them all up. So if I wanted to know the series of this sequence here, I would just take all these numbers, add them up, and then I would have my answer there. So go ahead and take a moment and write all that down. Okay. Again, you can always pause. So again, the difference between the two. And this is old, so let's get rid of that. That was when I did notebooks. We're not doing that anymore. Okay, so sum of a finite arithmetic series. So let's talk about the word finite for a second. Finite means there is an ending to it. There is, even though the sequence could keep going, they're asking you for an actual amount. So they could ask you for the sum of the first 5 terms. Or they could say, here are 4 terms, but we know the sequence could keep going, but they only want to know the sum of the 4 terms. Okay, so S of n is our sum. N, of course, is our term number, like always. A sub 1 is still our first term. And A sub n is the nth term. So for example, if I am wanting to know the sum of the first 5 terms, then I want to put the 5th term in that spot. Okay. Okay, so go ahead and try these first couple examples knowing the formula that you have. And I want to say I have one more down here. I sure do. Go ahead and try those 4. Okay, so like I said, if you always need more time, then you can always press pause and then keep going. So the first one, I always start out with my formula. So if I'm looking at n divided by 2, and the first term plus, and in this case, I'm looking for my 5th term. So your 5s will match. So if I notice, if this is where n was, then that's what that n is going to be. So 5 divided by 2. We have our first term, which is 16, and our 5th term, which they tell us is 28. So I'm going to just simply do 5 divided by 2, and then times the 16 plus 28. So the sum of the first 5 terms is going to be 110. Okay. So in this particular case, what I could do is I could find what the other terms are and then just add them together. Okay. So looking at the next one, I have S sub 7. I know 7 is n. My first term is 8, and I don't know my 7th term. So there's a couple of ways you can approach this one. You could either keep going in the sequence to figure out what the 7th term is, or you can use the formula from yesterday. So for example, if I use yesterday, the other day, a sub n equals my first term, which is 8, plus n minus 1 times my common difference. So if you notice, we're subtracting 6, so negative 6. Well, in this particular case, we're looking for the 7th term. So I can change my n to 7. And then all I can do is simply just do 8 plus 6 times negative 6. And I would get negative 28. So from there, I can take that and plug it in to get my final answer. Okay. Oops, and I put that in the wrong spot. That's the negative 28. Your answer is negative 70. Okay, so from there, let's try this one over here. Again, I start out with my formula. I fill in everything that I do know. I know my n is 5. My first term is 2. And I don't know what my 5th term is, but I do know my common difference. So if I start off with a sub 5 is equal to 2 plus 5 minus 1, and my common difference is a half. Again, I can do that, or I can keep going with the sequence, which in this case is 4. So then from there, just simply plug that into my formula. And I get 15. So the next one down here, I know my first term. Which in this case is 14. I know my last term, but what I don't know is my n value. Again, I can use the formula from the other day. I know that actually my a sub n, the term number that I'm looking at, is 116. My first term is 14. And I don't know what n is. And my common difference, I notice that I'm adding 3. So then I can simply distribute combined like terms, and I can figure out what my n value is. So I find out my n value is 35, and I just plug that in. And I get 2,275. That's a 5 there. My board's not letting me write it. 2,275. Okay. All right, go ahead and try this one out. Okay, so if we know there are 30 rows total, so I really like how these problems set you up to use both formulas and without you even knowing that they're asking you to do that. So if they tell you the first row contains 10 seats and then they increase by 3, so we know that it's going to keep going from there. It asks you how many seats are in the last row. Well, they tell us there are 30. So if we want to know how many are in the 30th row, we know our first term, we know we're looking for 30th, and our common difference is 3. So we should get 97. So that's how many are in the 30th row, but we want to know how many are in all. So we're trying to find the sum. So we know that 30 divided by 2. We know our first term, and we know our 30th term. So if you notice how simple these problems can be when you know the formulas. So I would highly suggest you write them out every single time, so that way you can be familiar. So if you notice, that would have been something that would have been very tedious. If you would have looked at all 30 rows and gotten 10, 13, 16, 19, and so on, and then added them all up, that would be a little bit too much. Or starting off by going 1, 2, 3, 4, 5, and so on, all the way up to 1605. Be careful with questions like this that ask you 2 questions in the same problem. I don't think I meant for that one to... Okay. So in terms of the arithmetic sequences and arithmetic series, then that is it for that today. And tomorrow we'll do geometric.